Hello, everyone. I'm with my new video on regular physics. And in this video, we are going to talk about waves. We'll try to understand the difference between mechanical waves and electromagnetic waves. And we'll be talking about transverse and longitudinal waves. So first, let's understand, what do you mean by a wave? Well, wave is a periodic disturbance that transfers energy. And in fact, there are two types of waves: mechanical waves and electromagnetic waves. So let's revisit the lesson objectives. So when you talk about the lesson objectives for waves, we'll be talking about mechanical waves and electromagnetic waves. We'll try to show how waves transfer energy, give some examples of transverse and longitudinal wave. We'll be talking about some examples of transverse and longitudinal wave. We'll try to define amplitude, time period, frequency, wavelength, and wave velocity. We'll be talking about the different parts of the transverse wave, like the crest, the trough, the compressions and rarefactions there of longitudinal wave. So we'll be talking about the different parts of a transverse and a longitudinal wave. We'll try to draw the graph of longitudinal wave and transverse wave. So displacement time and displacement position graphs of transverse and longitudinal wave. And we'll try to apply the relationship between wave velocity, wavelength, and frequency. So these are the lesson objectives. By the end of this video, you should be able to answer most of these questions. Okay, let's try to understand what is the difference between a mechanical wave and electromagnetic wave. Well, when we talk about waves, waves are periodic disturbances that transfer energy. And there are two types of waves: mechanical waves and electromagnetic waves. Now, when we are talking about mechanical waves, the definition for mechanical waves are the waves that require a medium to travel. Any waves that require a medium to travel will be considered as mechanical wave. And the waves that do not require a medium to travel are electromagnetic waves. Mechanical waves could be sound waves, because sound waves do require a medium to travel. When we are speaking, the other person is able to hear because the sound can travel through air. As far as electromagnetic waves are concerned, the electromagnetic waves do not require a medium to travel. An example could be light wave, microwaves, infrared, X-rays, radio waves, ultraviolet rays. These are electromagnetic waves because they do not require a medium to travel. Now, sometimes you might have seen in a science fiction movie an explosion happening in space. And when you watch that movie, you not only see the explosion happening, but you also hear that explosion happening in space. Is that scientifically correct? Well, that's scientifically incorrect, because when we are talking about outer space, in outer space, there is no medium, there is no air. So you should not be hearing the explosion. You can definitely see the explosion because the light waves can travel in space, because the light waves are electromagnetic waves. They do not require a medium to travel. But sound waves do require a medium to travel. So when an explosion is happening in space, outer space, you should be able to see the explosion, but you cannot hear the explosion. So technically, those science fiction movies are incorrect when they show you the explosion, and also you could hear the explosion happening in space. So in this video, for regular physics program, we will narrow down on mechanical waves right now, and we'll talk about the difference between a transverse wave and a longitudinal wave. So what is the difference between a transverse wave and a longitudinal wave? An example of a transverse wave could be water wave or waves in a string. Examples of a longitudinal wave could be sound waves. So those are examples of, or waves in a slinky. You can say you could have a longitudinal wave in a slinky. Of course, there are ways to have transverse wave in a slinky as well. But for example, you can simply write, as far as transverse wave is concerned, example could be water wave. And as far as longitudinal wave is concerned, you can answer sound waves. Now let's try to understand what happens in a transverse wave. Now, look here, what is happening? The particles move up and down and the energy moves forward. If you try to understand here, you see the particles move up and down and the energy moves forward. So in this case, in the case of transverse wave, the particles are moving up and down. The particles are moving up and down perpendicular to the direction of transfer of energy. So you see the direction of transfer of energy is represented by this orange arrow, and the particles, they vibrate at right angles. That is represented by these purple arrows. So oscillations and propagation, they are perpendicular to each other. This is a diagram to represent a transverse wave. You see a sine curve to represent a transverse wave, and the particles, they move up and down and the energy moves forward. Now, we need to understand the different parts of the transverse wave. Now you see the highest point of the wave, that is called as the crest. So this is the highest point of the wave, that is called as the crest. The lowest point of the wave, that is called as the trough. So you need to know what is a crest and what is a trough. The highest point of the transverse wave is called the crest, and the lowest point of the transverse wave is called the trough. Then what is the wavelength? The wavelength is the distance between two consecutive crests. So you see, it is the distance between the first crest and the next crest. So you have to answer as wavelength is the distance between two consecutive crests or two successive crests. You cannot simply write wavelength is the distance between two crests, because when you write wavelength as the distance between two crests, it might mean the first crest or the fifth crest. So you have to be very specific. Wavelength is the distance between two consecutive crests. Now, what is the amplitude? Amplitude is the maximum displacement. So you see the dotted line that you see, that's the equilibrium position. Also sometimes referred as the nodal line. So the distance between the equilibrium points and the crest, or the distance between the equilibrium point and the trough, that will be called as amplitude. Or you could also define amplitude as the maximum displacement of the wave from its equilibrium position. Now you see, this is the wavelength. So here you see the distance between two consecutive crests. It could also be the distance between 2 points in phase. So 2 points that are in phase. So like this point is in phase with this point. So the distance between 2 points, 2 consecutive points in phase. So you see, when you talk about this point and this point, they are in phase. So that could also be considered as a wavelength, or it could be also considered as the distance between 2 consecutive troughs. So here you see the definition of wavelength of any wave is the distance between 2 matching points on the neighboring wave. So if you're talking about, let's say you have this wave, you have this point, and you see the next point that is in phase with this point will be this one, because if you look here, this point matches with this point. So this distance would be the wavelength. It is represented by the Greek letter L, which is called as lambda. So this is the symbol for wavelength. Now amplitude, you see amplitude is the maximum displacement. So this would be the amplitude. So it is a maximum displacement from the equilibrium position. You see, from the rest position or from the equilibrium position, the amplitude is the maximum displacement. So from the equilibrium position to the crest, or from the equilibrium position to the trough, that distance is called as the amplitude. Now, higher the amplitude or larger the amplitude, greater is the energy of the wave. So remember that if the amplitude is higher, that means the energy of the wave is greater. Now we'll be talking about longitudinal waves. Now, what are longitudinal waves? As far as longitudinal waves are concerned, so in case of longitudinal waves, the vibrations are parallel to the direction of movement of the wave, so, or the direction of transfer of energy. In this case, you see the particles are vibrating back and forth parallel to the direction of transfer of energy. You see the particles that are vibrating back and forth parallel to the direction of transfer of energy. And the points where the waves are compressed, those are called compressions. And the points where the waves are spread apart, those are called as rarefactions. So for example, here you see, these are the points where the waves are compressed, and those are called compressions. And these are the points where the waves are spread apart, and those are called rarefactions. Now, when it comes to wavelength of a longitudinal wave, again, two consecutive points in phase. Now, if you see here, this is a compression, and that's like, this is the starting of the compression. So you try to find out, again, the starting of the compression, next point where the compression starts, and you find this is the point where the compression starts. So this distance would be considered as the wavelength. So you need to know what is compression. The points where the waves are compressed or bunched together, that's the compression. Rarefaction, those are the points where the waves are spread apart. Now we need to talk about frequency. Now, what is frequency? The frequency means the number of vibrations per second, or number of waves passing through a point per second. That would be frequency. So the number of waves that pass through a point per second, that is frequency, and it is measured in hertz, represented by Hz. So that's hertz. So one wave per second, that's 1 hertz. Sometimes if you hear the FM radio 512 megahertz, that means it is 512 times 10 raised to the power 6 hertz. It means that 512 million vibrations per second. Now, let's do some problems on waves. So when you're talking about some numerical problems on frequency, let's say if you have a question, 10 complete waves pass a fixed point in 20 seconds. What is the frequency? Now let's revisit the definition of frequency. Frequency means the number of waves per second. Number of waves per second. So you have 10 waves that pass through a point in 20 seconds. So you need to find how many waves pass through the point per second. And in order to find that, what you do is 10 divided by 20, and you will have 0.5 waves pass through the point per second. So your frequency is 0.5 hertz. So just keep in mind, frequency means the number of waves per second. Let's look at these questions. You may pause the video and try to answer these questions. There are 4 questions. You are supposed to calculate what is the frequency of 20 waves in 60 seconds, 100 waves in 120 seconds, 3 waves in 40 seconds, and 500 waves in 2 seconds. Pause the video and calculate the answers. Then we'll go over it together. Okay, let's go over the answers. The first one, it has 20 waves in 60 seconds. So we need to find how many waves per second. So that would be 20 over 60, and that would give you 0.3 recurring hertz. Next, you had 100 waves in 120 seconds. When you have 100 waves in 120 seconds, and you are asked to calculate the frequency is the number of waves per second. So 100 over 120, that gives you 0.83 hertz, 3 recurring. Now you have 3 waves in 40 seconds. 3 waves in 40 seconds. You need to find how many waves per second. So you see 3 waves in 40 seconds. So that would be 3 divided by 40. And that would give you 0.075 hertz. And then you have 500 waves in 2 minutes. Now, here the time is given in minutes, so you have to convert that into seconds first. So 2 minutes is 120 seconds. So in 120 seconds, you have 500 waves. So you do 500 over 120, and you get 4.166 recurring hertz. So this is how you solve these questions. Now, sometimes you might be given graphical questions, and you might be asked to calculate the frequency. You might be asked to read the graph and answer what is the frequency. Now, if you look at this graph and they say, and they ask you to calculate what is the frequency, and they say that this entire thing happens in 1 second. So if you see here, you have one wave, then you have again two wave, then you have the third one, and then you have the fourth one. So you see 4 waves pass through a point in 1 second. So its frequency is going to be 4 hertz, because that's the definition of frequency. Frequency means the number of waves that pass through a point per second. Here, when you read the graph, you see that 1, 2, 3, and 4. So 4 waves pass through a point in 1 second. So the frequency is 4 hertz. Now let's try to calculate the frequency here. You see, and this entire thing happens in 1 second. So let's read, this is one wave. And again, this is the second wave. So there are 2 waves per second. So if there are 2 waves per second, it means that the frequency is going to be 2 hertz. Similarly here, if you see one wave, then you have the second, you have the third, you have the fourth, you have the fifth, and you have the sixth. So there are 6 waves per second. So the frequency is going to be 6 hertz. So for the first one, it is going to be 2 hertz. And for the second one, it's going to be 6 hertz. Now we need to calculate what is wave velocity. Before we derive the formula for wave velocity, we need to know what is wave speed or wave velocity. Now, wave velocity is the speed or the velocity at which the energy of the wave is transferred. Wave velocity is not this wave or not the speed at which the wave travels. Wave velocity or wave speed is the speed or the velocity at which the energy of the wave is transferred. And the formula for wave velocity is frequency times wavelength. When you multiply the frequency with the wavelength, you get wave velocity. And of course, it is measured in meters per second. The unit is meters per second. If the wavelength is given in centimeters, you will have to convert it into meters. Frequency is measured in hertz. Wavelength is measured in meters. Now, using the formula V equals to F lambda, try to complete this table. So for example, here you have to calculate the wave speed. You are given the frequency and the wavelength. So you know V is F lambda. So you can use the formula V equals to F lambda and solve for the first one and the second one. Now the third one, you are given the wave velocity or the wave speed. You are given the wavelength. You are asked to calculate the frequency. So you have to rearrange the equation. Velocity is frequency times wavelength, and solve here. So when you're trying to rearrange, since V is F lambda, so frequency would be velocity over wavelength. Similarly, if you're missing the wavelength here in the fourth one, you will have to make wavelength as the subject, and that will be velocity over frequency. Pause the video and complete this table, and then we'll go over the answer together. Okay, now when you try solving, all you have to do is rearrange this formula. The first one is wave speed is frequency times wavelength. You need to calculate the wave speed. So all you'll have to do is multiply 24 times 0.6, and you get 14.4. The second one, again, you are asked to calculate the wave speed, and wave speed or wave velocity is frequency times wavelength. So that would be 30 times 10, which is 300. In the third case, you were asked to calculate the frequency. So rearrange this formula. Frequency would be wave velocity or wave speed over wavelength. And when you solve it, you will get 6 divided by 12, which is 0.5. Now, here, if you see, you're asked to calculate the wavelength. Now the wavelength would be wave velocity over frequency. Wave velocity or wave speed is 20, frequency is 20, 20 over 20, that's 1. Again here, you're asked to calculate the frequency. So when you're asked to calculate the frequency, frequency is velocity over wavelength. So 40 over 0.1, and that gives you 400. Then again, wave velocity or wave speed is frequency times wavelength, 100 times 0.2, and that gives you 20 meters per second. So you need to practice some of these questions. I've given you 3 questions. Pause the video and try to answer these questions. Okay, let's take the first one. The speed of the wave with a frequency of 10 kilohertz and a wavelength of 2 meters. So wave speed is frequency times wavelength. Frequency is given to be 10 kilohertz. Change this to hertz, so that would be 10 times 1000 hertz, and the wavelength is 2 meters. Use the formula phi is equal to f lambda. Frequency is 10 times 1000, that is 10,000. 10,000 multiplied by 2, and that gives you 20,000 meters per second. Next one. Your wave velocity is 11 kilometers per second. The wavelength of a wave traveling at 11 kilometers per second with a frequency of 5.5 kilohertz. So your wave velocity is 11 kilometers per second. That means 11,000 meters per second. And the frequency is 5.5 kilohertz, which means that 5.5 multiplied by 1,000. And you are asked to calculate the wave velocity. The wave velocity is given. You are asked to calculate the wavelength. So wavelength is velocity over frequency. Velocity is 11 kilometers per second. So 11,000 meters per second divided by 5.5 times 1,000, which is 5,500. And you get the answer 2 meters. The last one, the speed of the wave. You are supposed to calculate the speed of the wave when you are given the wavelength as 50 centimeters and the wave frequency is 4 kilohertz. So 50 centimeters, this needs to be converted into meters first. So 50 divided by 100, that would be 0.5 meters. And frequency is 4 kilohertz. 4 kilohertz would be 4,000 hertz. And you are asked to calculate the speed. So speed is, or velocity is frequency times wavelength. So 0.5 times 4,000. So you'll get 0.5 times 4,000, and that gives you 2,000 meters per second. So this is how you solve questions on V equals to F lambda. Another formula that you need to know is time period. Now, what is the time period? The time taken for one complete wavelength to pass through a point. So that would be time period. Or this is also the time taken for each wave to pass a fixed point. And time period is given by 1 divided by frequency. If you divide 1 over frequency, that's how you get the time period in seconds. Now, this is the formula. Time period in seconds is 1 divided by frequency in hertz. For example, let's say if the time period is given to be 10 raised to the power 9 hertz, you divide 1 over 10 raised to the power 9 and use the law of exponents, and you will get 1 times 10 raised to the power -9 seconds. Now, sometimes you might be asked to calculate the frequency from the graph. Now, you see, look at this graph, and you see this time period is 1/4 of a second because this entire is 1 second. So you will have, there are 4 waves, 1, 2, 3, and 4. So there are 4 waves. So once you're asked to calculate what is the frequency, frequency is 1 divided by the time period. So 1 divided by the time period. So time period for one wave is 1 over 4, and that gives you 4 hertz. Now there are some questions. I would ask you to pause the video and answer these questions yourself. Using the formula, time period is 1 over frequency, and frequency is 1 over time period. You are asked to calculate what is the time period for a wave if the frequency is 450 hertz, 19,500 hertz, and 0.01 hertz. So all you have to do is calculate the time period using the formula. Time period is 1 over frequency. So first one, you'll do 1 divided by 450. Second one, 1 divided by 19,500. For the third one, it would be 1 divided by 0.01, and time period will be in seconds. Now, what is the frequency of the following waves? A wave with a time period of 3 seconds. So frequency is 1 divided by time period. So this would be 1 over 3. This would be, here the time period is 0.005 seconds. So here the frequency would be 1 divided by 0.005. And here, this is the time period of 9 times 10 raised to the power negative 15 seconds. So what you do is 1 divided by 9 times 10 raised to the power negative 15. When you're using your calculator, make sure you put 9 times 10 raised to the power negative 15 within brackets. Otherwise, you will get a wrong answer. So 1 divided by 9 times 10 raised to the power negative 15 within parentheses. That will give you the right answer. So if you've solved these questions, you can check your right answers. Here are the right answers. For the first one, it is 2 times 10 raised to the power negative 3 seconds. For the second one, it is 5.1 times 10 raised to the power negative 5 seconds. For the third one, it is 100 seconds. For the second part, you are asked to calculate the frequency. The first answer is 0.33 hertz. The second one is 200 hertz. And the third one is 1.1 times 10 raised to the power 14 hertz. And lastly, we need to talk about the electromagnetic spectrum. You will be asked in exam questions regarding the wavelength and frequency of these waves. So if you look here, you have the radio waves, infrared, visible, ultraviolet, X-rays, gamma rays. Here there are microwaves actually, radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. And if you see the wave pattern, you can realize that the radio waves have got the maximum wavelength, whereas the gamma, they have got the minimum wavelength. Because gamma have got the minimum wavelength, they have got the maximum frequency. And radio, they have got the maximum wavelength, so they have got the minimum frequency. You are advised to remember the order of the wavelength and the frequency of the electromagnetic spectrum. So it starts like I'm going in the increasing order of the frequency. So radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. So gamma has got the maximum frequency. If we were to talk in the increasing order of wavelength, then of course the radio will have the maximum wavelength, and our order would be gamma rays, X-rays, ultraviolet, visible, infrared, microwaves, and radio waves. Out of all these waves, the only visible waves are this one, which we see. And out of that, if you see the red color, that has got the maximum wavelength. And that is the reason why it is used as a danger signal, because you could, that wave travels, or it travels, red waves have the maximum wavelength, or red light has a maximum wavelength, and it can be seen from the furthest distance. I hope you had fun watching the video on waves. If you enjoyed this video, kindly like it and subscribe to my channel for further videos.